Precipitation reactions are kind of neat. When you mix them together, you may not be able to see this great in the video, but you get some very small crystals forming. They can eventually grow to become very large, or some cases they stay very small to the point where it almost just looks like the solution is a little bit smoky. And you can see that here. In this reaction, what you see is that calcium ion and fluoride ion have been mixed together to give you calcium fluoride. So calcium ion plus fluoride gives calcium fluoride, and that's going to be a solid. But what's actually going on there at the micro scale? Now, what we're seeing is that these products are actually attaching to each other more strongly than the water molecules that were holding them apart. So if you picture water being kind of like my crazy ant on crack, you know, it's got the oxygen end right here, it's got a hydrogen end right here, and another hydrogen end over here as the other pincher. That's what we're talking about for the water molecule. It's grabbing hold of these charges, and you can see that it's got a certain amount of stickiness to try to pull loose with. But this full-size negative charge and this full-size positive charge are also very sticky. If this attraction is bigger than the total of these attractions, doesn't matter how good the water is, they're going to stay stuck to the other ions, creating a crystal lattice, also known as the solid. And as a result, we're going to get these small little crystals growing. You can see that over here in the picture. We have lots of little fluoride ions and some sodium ions floating around in the solution. But when they find each other, they snap together to start making small little crystals, or bigger little crystals, or much bigger crystals. And they're going to continue growing and growing. Left behind in our solution, we're going to have lots of these chloride ions. We're going to have lots of these sodium ions. Hey, sodium chloride. I know that molecule. That's the formula unit for table salt. So we'll see that around in the solution. Now we know that sodium chloride is going to be soluble in water, and so Na and Cl will be aqueous at the beginning. They'll be aqueous at the end. That makes them spectator ions. So that'll give us the net ionic equation that you see down here. In the net ionic equation, we take out our spectator ions to help you spot the thing that's actually changing a little bit more easily. Now, that's going to give us these big particles. Eventually, they'll grow to the point where they're large enough to settle out and create a solid in the bottom. And if we are careful with our experimental technique and tricky, we can even force these small crystals to become bigger so that we can just filter them. But there's lots of other ways of getting these out of solution, and that's outside the scope of what we're talking about for this one.